Next question is, bacterium can divide every 20 minutes, beginning with a single individual. How many bacteria will there be population if there is exponential growth of 30 hours? They'll ask you the growth for 30 hours. So we can say if there is one bacteria, right? So in next 20 minutes, it's going to become double. In the next 20 minutes, it's going to become 4 times. In next 20 minutes, 1, 2, 3, 4, 5, 6, 7, 8, 20 minutes. So we can say in a cycle of 1 hour, right? Basically 1 hour, 20 times 3 is 1 hour. So in 1 hour there are going to be 3 cycles. 1 hour going to be 3 cycles. In one cycle it just become 2 to the power 1 in one cycle. So the answer will be the very same. The answer number of bacteria will be the 2 to the power number of cycles. We just have to find out number of the cycle. In 1 hour 3 cycle. In 3 hour going to be 3 into 3, 9 cycles, right? So answer will be the 2 to the power 9, which is 2 to the power 9, right? This is 2 to the power 10, right? So answer will be the 2 to the power 9. Very easy. Just is the formula. You just have to remember this. Number of bacteria, right, is equal to number of cycle. Next question. If a birth rate of each of the 10 babies born in a hospital in days in find to be 2.8 kg, then the standard deviation for the sample will be. See, this is very easy question. They give you the mean and they ask you the standard deviation. They'll asking you the standard deviation, right? So I don't know why everybody is confused about this. Let's give you the simplest possible way, right? For example, there are 10 students in the class, right? And say the passing marks is 30 is your passing marks and average is just 50 marks, right? Average is 50 marks for your range. So if you say, if you got the 50 marks, you are an average. You are an average student. If you got the marks like 70, you are good. You are good student. If you get the marks of 90, you are topper, right? If you get the marks like 30, these are poor, bad student, poor student. If you get the marks like 10, you are failure, basically, right? That's how you decide, right? So 50 is your average, and how better or worse you are from the average, it is your deviation. It is your deviation. You got 40 marks, your standard deviation, like if the deviation is 20 marks, if you the person, the topper is 2 times ST better than the mean. That's what standard deviation is. How better or worse you are, right? So standard deviation can be positive, can be negative, right? It's just based on the mean, right? So we just have to find out if average, actually mean is 2.8, but for everybody, right, everybody it is 2.8 plus 2.8 plus 2.8 plus 2.8, right? That's how we'll find out for 10 students, 10 child, basically 10 babies. So it's just going to be 2.8 only, right? 8 is your mean. 2.8 is your mean. And if everybody have the weight of 2.8, so who is good, who is better? Nobody is good, nobody is better. Nobody is heavier, right? And nobody is lighter. So everybody have a fixed rate. So deviation will be 0. There is no deviation. Nobody is heavier, nobody is lighter. If the deviation of say 1 kg, so a person who have 1 kg, like 3, if say for example the standard deviation come out to be 1 kg, so as to like a child which have a weight of 2.8 plus 1 kg, basically 3.8 kg, he is heavier, right? is heavier or is healthier than your normal from the average. So in this case standard deviation will be the 1, but if there is no other, everybody have the same weight, standard deviation will always going to be 0. Next case, among the 100 women with an average HB of 10 grams, the standard deviation is 1. What is the standard error? What is the standard error? Now we just have to understand what is the standard deviation mean. For example, the HB mean is 10 gram, right? So standard deviation is 1. What does it mean? What does standard deviation mean? Well, maybe you can say that there is someone who has a 10 plus may 1 is equal to 11 gram weight, right? We can distribute them in this graph, right? So this is your mean, and this is where 1 sigma lies, which is where 2 sigma lies. Sigma is your standard deviation. So at this point they have the 11 gram hemoglobin, right? At this point they have 12 gram hemoglobin. This is negative 1 sigma, this is negative 2 sigma. So in this point they have the milligram will be 9 milligram, and here is the 8 gram hemoglobin. So it's just their value, standard deviation is plus or minus than mean. So this is your standard deviation. Now they are asking you standard error. They are asking you standard error. So how do we find out the standard error? Standard error is standard deviation divided by under root of sample size, right? Just very simple formula. Just have to apply standard deviation is given as 1, number of women is 100, right? Under root is 1 by 10, so standard error is 0.1. The answer will be the 0.1. Where is, you just have to remember the formula, right? You in this case you don't even have to think about this, just you can even forget about this. They'll ask you the standard error, just ST upon mean number of sample by under, where is, right? Next question, it is also one of the most difficult questions they ask me. So it's very easy if you understand it. The concept is very important. The population of 2000 people with mean hemoglobin being 13.5 having the normal distribution. What population of what portion of the population constitute proportion more than 13.5 gram? They're asking you which all have the weight more than 13.5 gram. So what is the, see here the 3 keyword. You can forget this. This is not important. This is somewhat important, and the main point is normal distribution. This is where answer lies. This is what they mean by the, if they ask you what is the normal distribution, this is your normal distribution of the values. What does it mean? For example, if we mark out the hemoglobin values, right? These are the people and these are the hemoglobin value. 13.5 here, 14.5 in the year. We are taking standard deviation as 1 only, so we are just going to add the 1 value, right? And here we are going to reduce the 1 value. Easy. This is your standard normal distribution. Now there are other kind of distribution. They are positively skewed when they are more of, this is positively skewed and negatively skewed graphs, right? In this you can say their values are mostly in this area, right? You can say they are more of a, more people, more women, like more people have less hemoglobin. So you can say population is unhealthy. In this state, you can say more people have more hemoglobin than normal, right? So you can say they are kind of healthy, right? So this is the basic concept for the normal distribution. You just have to look out for the normal distribution. If they give you the normal distribution, your answer become very easy. All the people have the movie, like all these people after the 13.5, they are better, like they have the weight, they have the hemoglobin more than the, these people are more than the 13.5. So all these people have the less than 13.5 gram, less than the 13.5 gram, and right. So all the people are, these are 100%, these people are 100%. So 50% have more than that, and 50% have less than that. So answer is very easy, 0.50. But if they give you, if they do not tell you that it's a normal division, if they give you a positive or a negative score, then your answer become very difficult, right? Your answer become difficult. Then there are different way to tackle that, but this is the main thing, right? Now here come to the last question. The fasting blood glucose level of group of diabetes is found to be normally distributed. The key, normally distributed with the mean of 100.5 mg per 100 ml of blood and a standard deviation of 10 mg. Standard deviation of 10 mg per 100 ml of blood. So you can say, here are the keyword, normal distribution, right? So you can see a graph is going to be like this, easy, 50% good, 50% like below it, 50% more than it. Mean is, if they are given the mean which is 105, so basically this point will be your 105, and the blood and standard deviation of the 10, standard deviation is 10 mg. Find the data can be inferred for approximately 95 on the diabetes will have the fasting. So they are asking you what will be the data amount of the, like they are asking you the range, right? So 90% of the people, what is the range for their sugar, what is the range for the blood sugar? So if we just draw this graph a better way, right? So if we draw it like the previous one, right? So this is how it's going to be, right? It's a standard, it's a normal distribution graph, it's a normal distribution graph. So if you look at it, here are mean is 105. So you can say this is your 105. The standard deviation is 10. So you can say this is your first standard deviation, 1 sigma, it is your 115. This is your 2 sigma, it is going to be your 125. This is your minus sigma, which is your 95. This is your 2 sigma, it is your 85. Then you go for the very back 3 sigma, 75, and you can go for 3 sigma, 135. Very easy. So this, if you, these are all the, these values you have to remember. All these people within the first sigma, all these people between from your first sigma, say people from the 95 to 105, these are constitute your 68% of the people. These are your 68% of the people. So you can say this much is the, from the people say from the 105 to 115, these are going to be 34% people. These are your 34% people. How I remember these? They are just the straightforward factual values. There is no formula for it. You can just remember as factual values. So from your minus sigma to your plus sigma, these are 68% people in this, in any normal distribution. Remember, only in normal distribution. That's why that term is very important. If they give you the normal distribution, the people from minus sigma to plus sigma are 68.33% basically. From the 2 sigma to your 2 sigma, minus sigma to plus sigma, these are your right. So if you mark out these people, these are your 95%. So from your minus 2 sigma to your plus 2 sigma, these are 95% people. Here the third one. What about 3 sigma to 3 sigma? These are 99% people, 99.7%. 3 sigma to plus 3 sigma, these are your 99% people. So they are asking you about the 90, that's why they give you the exact 95%. They are asking you the 95%. You just have to go for it's 2 sigma minus 2 sigma to plus 2 sigma. So the value is very simple, 85 to 125. The answer is 85 to 125. Right? This is your correct answer. Right? What is the 75 to 30%? They ask you about the 99% people. Easy. And for this is your 68% people. Simple. And this is go beyond. This is out of the range. Basically, there are more of 100% people, you can say. Just about 100% people. So this is all your question. Thank you very much. If you have any doubt or you want me to discuss your questions, you can always send your doubts to my either in comments or in Telegram or on Instagram. Thank you very much. Have a nice day.